we are ensuring success for top-tier customers around the world. Our second speaker will be Kim Delgado. Kim is a customer success architect in the Global Services Organization, focusing on automation, orchestration, and integrations. She has been with VMware since 2010 and been part of the Hands-on Labs program since 2012. Kim is also an ambassador to the Office of the CTO at VMware. Before we start, I'd like to remind all guests that they are muted. Please do pose questions using the Q&A feature at the bottom of the Zoom window, and we will respond to them throughout the session. Mandy and Kim, over to you.
Great, thank you, Robin. Well, cloud automation services are comprised of three new SaaS offerings, which together make up the next generation of VMware's automation tools. Managing clouds is complex on its own, but when you factor in public and private cloud, multi-geographic regions, and application delivery, that complexity grows exponentially. This complexity risks creating silos of knowledge focused on individual cloud skill sets for both public and private clouds. This means that leveraging a tool that makes the clouds invisible and abstracts their configuration is really critical to the success of your cloud strategy. Today, you will learn how to design a cloud experience that will not only solve your infrastructure problems, but will also be easily consumable by your internal customers. As you watch the demo today, I'd like you to start thinking about how you can leverage your users a consistent experience, regardless of which cloud they're using. Robin did a lovely job of introducing us already. So I'll only add that Mandy and I together are also known as Team Candy. You can see that information at the bottom of the screen. So today we're going to go through an overview of cloud automation services, and then Mandy's going to give you a fabulous demonstration of how you can build blueprints and deploy workloads, and we'll be taking your questions through the Q&A as we go. So as I mentioned, clouds can be the new silos if you're not careful. We know that most organizations use public clouds and private clouds today. A recent survey suggests that 67% of VMware customers believe that they'll be using 2 or more clouds for their application needs in the near future, if they're not already doing so. The reason, of course, historically, is that IT always prioritizes control with efficient, secure, and being efficient, secure, and reliable over agility and speed of delivery. In the absence of that agility, shadow IT has almost become a universal phenomena in most organizations. Lines of businesses, developers, and finance and marketing orgs across all organizations have embraced solutions that help them move faster without formal consent from IT. Many studies show that organizations often underestimate the size of shadow IT by as much as 10 times. So, of course, for IT folks trying to make sure that they maintain that visibility, that's an ongoing struggle. As organizations begin using these clouds, they quickly realize that, for starters, these clouds can be very expensive. They also begin to notice that they're difficult to manage because they all have different technology stacks, they all have different API layers, and they require different skills and different tools. So the way you provision, secure, and manage the lifecycle of your applications on vSphere is very different to the way that you would do that on AWS or Azure. And finally, because of these inefficiencies, organizations often realize that they lack that visibility and proper security, which can make them exposed to a huge amount of business risk.
Ordering food on your phone, getting a ride on your phone.
Making clouds invisible is really about removing those silos that we just talked about. So again, the lack of visibility, the operational complexity, and the increased risk exposure. increased risk. So we take a multi-cloud approach from the top of the line SDDC technologies, our partners, including VMC, and to the best-in-class public clouds that span a spectrum of personas, from cloud administrators and SREs to developers and DevOps admins. To enable invisible clouds, you need to start by anchoring your private cloud with self-driving operations so that you can continually optimize performance to meet business intent. You need to provide choice for internal customers through a unified provisioning approach to any cloud type. And you need to allow end-to-end visibility, agility, and speed via application operations to get code and applications out as fast as possible. Our cloud automation services and multi-cloud are multi-cloud by default. We put the abstraction layer across the clouds and expose the APIs. These APIs can be consumed through the blueprints that are provided through Cloud Assembly or through other application frameworks such as Cloud Foundry, PKS, functions as a service, etc. On top of this, there can be a catalog for self-service experience, business policies, including approvals and entitlements, and a release continuous delivery pipeline through CodeStream. Our cloud automation services, again, primarily encompass these three services: Cloud Assembly, Cloud Broker, and CodeStream. Cloud Assembly is the component that allows you to automate and expedite the infrastructure and application delivery in line with DevOps principles. It's a declarative infrastructure as code cloud abstraction layer where all of your blueprints are going to be created. Service Broker is our multi-cloud catalog, and that allows you to aggregate the native content from multiple clouds, not just Cloud Assembly. And it gives you a single catalog with tag-based policies to provide those services to your end users. Again, it's an aggregator of content that provides self-service for Cloud Assembly blueprints, as well as third-party content such as AWS Cloud Formation templates, ARM templates, etc. And it also gives you a governance layer on top of that. And last but not least, CodeStream is our continuous delivery pipeline. It speeds software delivery and streamlines your troubleshooting with release pipelines and analytics. It also allows developers to model the entire release process and be able to manage that through those services, and also provides dashboards for you to be able to keep track of your release KPIs. So we'll walk through a little bit more details on each of these and then give you some demonstrations. From a Cloud Assembly perspective, these are really your key components that you'll need to be aware of. So if there's folks that are familiar with vRealize automation or other automation tools, some of this might look a little bit familiar. Up at the top, we have our projects, and projects really are just groups of users who are consumers that can access, where we can give access to specific blueprints and allow our consumers to deploy them to the infrastructure which we've given them access to. The infrastructure really is made up of cloud accounts and cloud zones, as well as mappings and profiles. Mappings focus on flavors and images, and profiles focus on network and storage. Both of these components really are brought together in our blueprint, and you may be familiar with the concept of blueprinting, but it allows you to define the infrastructure and the application details in a common format and common language, and then that can be translated by Cloud Assembly into cloud things. So that could be VMs, networks, storage, or anything that you can define there. And then last but not least, deployments are the actual instances of your blueprints. So once your users actually request a blueprint, they're given a deployment which will look a bit like the blueprint itself, but those are your actual VMs and networks. We love tags. So tags come in different flavors within CAS. We have constraint tags, which you can kind of see on initially. Those come from projects, images, and blueprints in that order. That's the order of hierarchy. And we converge all of those tags when we send those over or merge those with our capability tags. So capability tags are going to live on the cloud zone, the storage, and the network profile. And that allows us to drive intent through the blueprints and through those other objects by mapping those to our capability tags. And then ultimately, we can also tag the things that we're creating, the cloud things, with tags that will then live in the endpoint. So we can use those to automatically create or consume those tags at provisioning time. So they can be then used to query or monitor your environment on your VMs or other things that we've deployed. So there's an example. We can tag VMs with a priority, with a type, maybe with our backup details based on input that we've received from the requester at request time. So in order to configure cloud automation services to be able to support VMware, the VMware Cloud Endpoint, VMC as an endpoint, there's a few steps that we have to take. First of all, we have to make sure that VMC allows us to actually communicate with cloud automation services. So we set up some firewalls in VMC. Then we need to deploy a cloud proxy to the vCenter endpoint in VMC itself. The cloud proxy is going to be a virtual appliance that you actually download from CAS and deploy as part of your integration or your initial configuration. That registers back to your cloud automation services organization and gives us the ability to communicate with that vCenter. And then we need to, of course, also provide authentication details to our cloud account. And then we will set up our tags and filters in the cloud zone. So we create a cloud zone for that specific VMC instance of that cloud proxy.
And I do want to bring up, Kim, one point that's really important with the tag and filtering the cloud zone. We'll look at it in the demo, but it's essential that you tag and filter the zone so that it will deploy into the compute resource group so that you don't accidentally attempt to provision into the management resource group, which will then fail. So we'll look at that as we go.
Good point. So on the next slide, we actually just have an overview of the specific VMC firewall rules, which are prerequisites. Those are documented, and we'll give you some links to the documentation when we wrap up. But do be aware that it does require outbound access for various purposes. We need to be able to allow inbound access to vCenter from that cloud proxy that we deploy onto the vCenter. We need to allow inbound access to the NSX manager from the cloud proxy, because again, we're going to be deploying both virtual machines and networks. And we need to allow inbound access to the ESXi from the cloud proxy when we use OVF deployment from cloud automation services. And last but not least, we need to be able to allow outbound access to the internet from the cloud proxy service, because it's a one-way communication from the cloud proxy out to the cloud automation services running as a SaaS offering, and then it will pull down the requests from cloud automation services. So it's really only a one-way communication. It reaches out to CAS and retrieves the work that it's been assigned from CAS. And then we also need to be able to potentially download updated containers. So when we refresh code, that cloud proxy automatically gets updated. All right, I think I'm done with the intro, Mandy.
All right, sounds good. That means it's my turn. It's demo time. I will say with the firewall rules, if you notice there, the first three were all kind of internal within the VMware cloud itself, and there's only one rule that's outbound, and that's the only communication, as Kim emphasized, that you have to have. All right, let me get this switched over to share my other screen. All right, so now you get a chance to see this. You've heard a bit about it, and as you can see within the Cloud Services portal, you have the opportunity to see the services that are available. These three are the ones we discussed that are the cloud automation services. But as you can see, the other services are available there as well. For example, the VMware Cloud and AWS that you may be familiar with. So I'm going to start by taking a look at Service Broker, which is the catalog. Oh, excellent. This seems to be a theme. There
At
we
least
go.
it's my computer this time.
Yeah, exactly right. So here we can see a high-level catalog where we have provided particular users some cloud assembly blueprints, but you can see here, you can also do AWS cloud formation templates as well, as Kim talked to. These blueprints are uplifted and provide you with the same inputs, all defined as code. So we can do a deployment name. You ultimately can choose your project. I have only enabled it for the demo project, as we talked about. Environments, these are, again, all defined in the code. So we can choose our particular environments and our app tier size. So we'll go small so I don't use up too much space. And this gets submitted. These deployments are then available through cloud automation services as well in the cloud assembly, which I have to log back into. So now if we look at cloud assembly, you'll find within the deployments that we can see the same one also provisioning. So the service broker engine is the same engine that we have in cloud assembly. Now, while that provisions, we'll take a look at it in a minute, we can take a look at the blueprints that we have available. So we have particular blueprints that we have listed for our projects. I have filtered this by project. There are other projects that are available that may have blueprints as well. But we will take a look at our demo project for now. And you can see what we've done is enable these via source control. So these particular blueprints are actually stored in Get and synchronized in to our environment. Because the blueprint is essentially code, you can store that all as is in a repo that then is shared potentially between projects as you move forward with that. So if we look at, let's drill into, actually, what I'm going to do is I'm going to clone this particular blueprint. You can see we have other options. You can also upload straight code. But I can start this one, put it into my project, take the current draft of it, and then we can edit it to our heart's content. When we drill in, we can now see that we have a multi-tier application that can be provisioned. In this case, it uses a mixture of cloud-specific elements and cloud-agnostic elements. So this one is being provisioned into AWS native. We will show you blueprinting to VMC in just a moment. You can see the inputs that we had from Service Broker are defined here in the code itself. And you can drag and drop elements onto your blueprint canvas. And then you can notice that that is immediately shows up in the code. You can see visually that we need to give this a name as we go. This shows up as red. And make that change. But we can also change things in the code. If we go up here, for example, I can change this binding. You can see it drops down with IntelliSense there into the network 3, which will immediately reflect onto my canvas. So changes can be made on the canvas or in YAML, and the two things are kept in sync. The elements that you have available include a number of cloud agnostic elements like machines and load balancers and networks, the volumes. These can be provisioned into any cloud that you have an endpoint to. So that would include VMware Cloud and AWS. It could go into a private cloud on premises, as well as AWS, Azure, and as we add more clouds, those will be available too, like Google Cloud Platform. You can also have specific elements. For example, you can add vSphere machines, disks, and networks. Those would only be able to be provisioned into vSphere specific clouds. NSX elements are the same way. Now, as you see here, these ones have AWS elements. So this particular blueprint can only be provisioned into AWS to be successful. There are a number of services that you can link in as well, from AWS to Google Cloud Platform specific machines and disk, Kubernetes clusters, and a number of Microsoft Azure elements as well. And I should note that you can also do configuration management with Puppet, all as part of the blueprinting engine and defined within the blueprint. Now, what you may also have noticed is that this particular blueprint has cloud config defined as well. That's going to actually install the various tiers at deploy time. So it will go out to get and deploy the front end, that API, the cache tier, the database tier, and load the database as part of it as well. So that's our database tier. You can see we have a unique defined cloud config within our code here, as well as for the API tier. There's the installation and our front end. Now, if we look back over at our deployment, the deploy happens, at the speed of the cloud itself. And in this case, our deployment has completed, and we can grab our public IP on the front end and look and see what we've actually deployed. And I am consistently having a challenge copying this. Kim, I'm going to need you to remember my IP address. Nope, I got it this time. All right. So in this case, it's deployed the multiple tiers, and we have our Plane Spotter application up and running and ready to roll. Now, what I want to show you is how to actually do some of this from a VMC perspective. In this case, we can start a new blueprint, and you can see how quickly blueprints can be created to deploy a particular workload. Again, it's all project-based, as we discussed, so we'll go ahead and create it in our demo project. And now we have a blank canvas. I can choose in this case, for example, to add in a cloud agnostic machine. I'll need to give it an image and a flavor. So for example, I can choose to give it a CentOS image, and I can choose my flavor. These have been defined by the cloud admin so that I have a user-friendly perspective on what my images and flavors may be. What small really means, the cloud admin has decided. We can take a look at that in a moment, as well as what CentOS means has been determined. Now, an additional element that I can put into play here for our particular machine is I may want to put those constraint tags into play so that this one sorry there, we'll go to a particular spot. Is that right? Well, oh, I forgot my space. There we go. We need a team programming here.
Yep. And again, this comes back to the constraint tags that we talked about earlier, right?
Yes. There we go. So it will help you out as you get going. So we can do this. And this is then a constraint tag. Now this, perhaps, we would want to be a little bit more thoughtful about what our tags may look like. You may have PCI environments, you may have prod environments, you may have test environments, and things along those lines. In our previous blueprint, we saw we had environments like prod and test and dev. In this case, I'm going to actually tag this directly to Cloud VMC. I've defined this particular tag, and I want to force this machine to go into that cloud. All right, I believe everything looks pretty happy here. So the good news is you can go ahead and deploy right away. We'll go ahead and do that. We can use our current draft, and we can deploy this. Should now go into VMC. We'll let that move forward, and while that finishes up, let me show you some of the other elements. We may want to add a network into our machine, right? As we do that, like we saw before, you can drag and drop those networks in, and you can pull them across. The only element that you need to then update is you will need to give it a name. Not a very interesting name, but we have now added that name. Now we can also then version this particular blueprint. And we can add in the description or changelog. And now we have more than one version of our blueprint. You can see if we look at the view, you can see the current draft. We did not version the first one, so we see this one. There you go. Now let's see if we flip back over to our deployments. Have this finished yet? Not quite. There are other elements that we can add in. For example, there's an opportunity for both cloud agnostic load balancers, or you can choose to be really specific and designate an NSX load balancer. The difference between choosing the two is that if you take a look at the cloud agnostic elements, you will have particular properties. And if you add in the NSX load balancer, it will specify that with very similar properties that are available. But it will determine that it must use the NSX load balancer as opposed to whichever cloud is available. We can delete that element, and I will show you again, if we delete elements directly, from our code, it then disappears as well. So this particular deployment is now complete, and it deployed simply our cloud virtual machine. And I have already, assuming it's not logged me off, nope, every time. So let's close this down. Yeah. Let me go back in. So we will go into our org that has our VMC. I'll show you how you can get logged in. Need to show the credentials. We will copy this and open our vCenter. And now we have our machine right here in our VMC environment. You can see it's a 38997, and here you go. We've got the same machine that shows up there. Now, you will see in here, it's important that you have your cloud proxy. That is what Kim had already talked about. One of the configuration steps is to have your cloud proxy installed. You need to have a cloud proxy for any vCenter-based environment, and you're going to want that to be available on the vCenter where you'll be collecting inventory and provisioning workloads. And then because your VMC has both a compute resource pool and a management resource pool, we need to ensure that we tag our cloud zone for that. So let's go over and take a look at that. In our infrastructure, we have our particular cloud accounts. Here is our VMC cloud account. The elements that you have to do is you must have an API token. It clears that, so it's not applied there. You can see that we're using the same SDC name, and it will automatically fill in and configure the NSX manager as well as that vCenter IP based on the SDC name. We only need to provide it with the vCenter password as well as our cloud proxy. We then choose which data center we will configure that to and add any capability tags. So that's that step we talked about in terms of authenticating our cloud account. Now, the cloud zone does have a little bit of a tricky bit, because what we need to do here in our cloud zone is be sure that we are filtering to only get in our compute a particular tag. In this case, I tagged it with Cloud VMC for our resource pool. If I remove this filter, you can see that it has available the other clusters and resource pools. If we don't tag it, it may attempt to deploy workloads into the management resource pool, which will result in failures due to permission issues where VMC is locked down, of course, in the management resource pool. So if we filter it like that, then it will only provision into our compute resource pool. You can also configure particular cloud zones for this purpose if you have additional resource pools that you want to segregate workloads into based on project. Well, we can save it, it doesn't really matter. All right. Now, I did want to point out regarding the flavor mappings. I mentioned that I had configured the sizing, and that is true. And if we look at small, small means something, and it means something a little bit different for each environment. For AWS, it means a T2 micro. For my vCenter, it means, typically 2 CPUs and 1 GB of RAM. However, for my VMC, I actually did that as 1 and 1. So I, as the cloud admin, am able to define what small means, and that means something across cloud. So it doesn't matter which cloud I provision to, small has a definition particular to that cloud. The same is true for things like image mappings. For CentOS, I actually only have it mapped right now for our VMC, which is what we provisioned there. However, for other operating systems like CoreOS, that has been defined in other vCenters as well on-prem, as well as AWS and Azure. So by choosing an image for CoreOS, it will choose the appropriate image that maps there for the cloud that we are provisioning to. As we talked about, you can define network profiles and storage profiles as well. And our projects are key to defining where things, how things are managed, both for users, for cloud zones, for blueprints, etc. Now, let's flip back over to this particular blueprint. Yes.
Sorry, Mandy, I wanted to show something real quick back in the infrastructure tab.
Sure thing.
Again, this is a SaaS offering. So you can see here that we've got some new features that are introduced as beta features in the product, and they'll be tagged with a tagline beta. So Kubernetes profiles and clusters, that functionality is beta right now, but because it's a SaaS offering, we can continually offer updates. And then once that feature actually has been fully vetted, it will GA and we'll remove that beta tag. But you can see how we're introducing features on an ongoing basis, as well as updates to the existing code.
That's a good point. Thank you. And I have access to the beta elements right now. So it depends actually, I believe, on your organization settings, which beta elements that you're able to see. So that's a good point.
Correct.
So this particular blueprint, we had provisioned it into VMC without a network, right, the first go round. Now, because this is both declarative intent, right, so I intend this to go to VMC, I intend to use CentOS and small, whatever those are defined as being, but it's also iterative. So I deployed this blueprint with just a cloud machine. I can now deploy it again, and I can choose, rather than a new deployment, I can update my particular deployment. So that was the VMC test that I had done. When I deploy that, it's going to give me a plan, and it's going to tell me what it's going to do. It's going to add something, right? My cloud network, because that was new. And it's going to, in this case, recreate something, which is the cloud machine, so it can connect it to that particular network. In other cases, it may remove things based on how you have modified that particular blueprint.
Yep. In this case, it actually needs to recreate that machine because the original one didn't have a NIC that we can use to attach to the network. But if you're doing things like adding storage, it'll often just update the machine. It won't actually recreate it.
Mm-hmm. And it depends on the cloud and what it's attempting to do.
Exactly.
So while the flavor, you can increase the size and hot add CPU on vSphere type environments, it doesn't work that way in AWS native or Azure native. So it will recreate that machine if you go from a tiny size or a small size in AWS to go to a larger size. So it depends on the particular cloud and what it's attempting to do, but it always will show you what's going to happen when you deploy your blueprint. There are some additional elements that are worth pulling up. We've looked at the base infrastructure tab, but I think it's worth pointing out, for example, there are integrations. You can integrate to the GitLab, which we saw for blueprints. You can actually have a many-to-many integration. As you can see here, we have 2 different GitLabs, or you can use GitHub. We also have the ability to integrate using vRealize Orchestrator. I have one in my private cloud that allows me to do extensibility using vRealize Orchestrator in a private cloud environment. And then you can connect your VMware account to allow you to take advantage of the marketplace, for example. So if we take a look at the marketplace, it's integrated directly into the Cloud Automation Services so that I have the opportunity to find and download particular blueprints if I would like them for examples and the basis to move things onto. So let's see. This is we have for example, a WordPress example which shows you multiple tiers, and that's a hybrid using RDS and EC2, so AWS native. We have one using an Apache HTTP server using Puppet. There's a number of different ones that are available, and it's a growing community, so more things will come as we go. So I can, for example, let's click on, we can get this particular blueprint for just a WordPress basic to give us an example. I can either download it or add it directly to a project. So in this case, I can add it directly into my demo project, and we have that there. But let's actually take a look at this multi-tier web application with the on-demand. We can get this one, for example, and I could download this to my local computer. When we download it, we can see, oh, no, I don't want that. I will share this with you. Give me one moment.
So yeah, all of these marketplace blueprints are really intended to be sample code. They may not work straight away because obviously the specific components called out in the YAML here in terms of images and flavors and whatnot might not match what you have defined in your environment. But generally, they try to be they try to use pretty generic options.
Exactly right. And so you can see here, this is the code that is the YAML code that you would see in the right-hand pane. And this defines the whole blueprint. It's all, human readable YAML. And as Kim mentions, it may have particular things predefined, like, the Ubuntu image that you need to use that we would have to define. But we can import this. So let me switch back. Now, if we go back to our blueprints, we can upload. We can choose our particular project, and we can choose then the file. Hold on here. And there we go. We have our file selected. And now I can upload this example. Now, if we dig in here, if I click emphatically enough, it now brings up this particular example blueprint that shows us how we can use, for example, a load balancer with a web app and a MySQL across 2 networks using these particular networks, load balancer, right? You've got your apps. And this is the YAML that we looked at just a moment ago. Now this one will not quite deploy yet because I would have to fix the image, for example. You know I have an Ubuntu image, for example. I don't know if this one would deploy with that, but you could fix it to make your things function the way you need it to. Now, I did that and I got something red and it says, oh, look at that. You have a default value, Ubuntu there, and it's not listed in the valid values. Well, luckily, these things help me out and I know how to fix that within there. But this is the same code that we saw listed in our download, right? Or that we would store in our Get repository. And it shows up here and gives you the visual display.
This was a great example of using Cloud Config as well for installing software, pulling basically code from a repo and installing software on as the machines are deployed.
That's right. So what I might do here is I've done a little bit, right? And you might want to version it so that you have that for future. Now, once you have versioned your elements, if we look at the version history again, I know we've looked at that once, but what I wanted to show you is that it's through here and in this release system that we publish up into the catalog. So by releasing this particular blueprint, that would allow us to come back into Cloud Service Broker. And then we can configure it into Service Broker. So it doesn't show up immediately. Instead, we have to dig in a little further into our content sources and our content sharing. Now, I have in these sources, you can see 3 options. I've got Cloud Assembly Blueprints, AWS CloudFormation templates, and I've been playing with the vRealize Orchestrator workflow beta. So as you can see, you'll be able to uplift your workflows into Service Broker to do anything as a service using vRealize Orchestrator as well. Again, everything is essentially project-based. So you can see the various elements that then are shared with the particular project. And I have to drill back into here. And it now has found 4 elements for our items there. And now we have our NSXT item there as well. So we can make sure that we have these elements all in place. So there is our NSXT example. And you can see, for example, we have our projects. You can see our image reflects what I had listed in the inputs and how I had changed that. And then we have the node sides that are available there as well.
So a couple of questions came through on the chat. Can Cloud Assembly deploy from OVA and OVF? The answer is yes. That's why we had to set up that one specific firewall rule. So we can, I don't think we have any blueprints maybe that show that directly, but we do have that capability. And the other one, the other question that came up is, could you please talk about how much of these capabilities are API accessible? And the answer to that is everything. It's an API first approach that we've taken with all the development that's happened with cloud automation services. So yeah, so you can actually access pretty much any of this functionality, but it's especially anything that you can do in the catalog is all API accessible.
That's right. That's right. It's all API first, and so therefore accessible via the API. Depending on you know, what you're looking to achieve, in a lot of ways, you may take the catalog, right, and pull that into your particular service catalog of choice. That makes a lot of sense. You know, trying to do some of the blueprinting engine maybe doesn't make quite as much sense there. I do want to point out that there is additional extensibility options as well. We have event topics, so it's an event-driven extensibility, and you have the opportunity to, on particular event topics, take actions which are occur out in the cloud, right? So they are essentially like function as a service that exists out in the cloud. So the actions work really well for things that remain in the cloud. You can see this example, for example, shows us ServiceNow. So if you wanted to update your CMDB when you provision machines in ServiceNow, that is the perfect example of something that may go into an action because it should remain over the internet. Now, the other element that you have is that you can do workflows and configure those to occur on particular event topics as well. So it would depend on the cloud that you're provisioning to, which element you may do as well. So when you're doing VMware Cloud on AWS, you may want to do vRealize orchestrator workflows from within VMware Cloud to do particular elements. Here we see all the workflows, 662 of them, that are available from that vRealize orchestrator that you saw I connected to previously. So you then connect these into particular subscriptions. I don't have any at this point. So we would have a particular subscription, and then we would click it to a particular event. So we might do that on a provision event, right? And then we would choose what our runnable item is. So right now, I don't have any of the workflows set there. So I would say on provision, let's do a ServiceNow integration. We can choose whether this is a blocking event or whether it's a throw over the wall and go. In the perspective, if it's a blockable event, you may need a recovery item, right? If this fails. In this case, we wouldn't need to do that. We could choose to throw it over the wall, or we could choose to block it depending on what we want to do. And in a recovery event, you know, maybe we would send an email or do something along those lines. And then you have a scope, right? Do we scope it to any project, or is this something that I only want to happen in particular projects? So I might say, I only want to do this particular one in the demo project, and I don't want it for, you know, my dog's project, because in that case, it's a dev environment, and you know the workloads are very ephemeral, and so I don't want to track them in ServiceNow. But demo have longer lived workloads, and I want to do that there. So these are the types of aspects you can do. You can filter it as well. I don't think I brought that up as to when this particular event happens. In my case, I want it to happen all the time.
Often. This is really great stuff. I just want to call out that we only have a few more minutes left. So if anybody else has any other questions that they want to post in the Q&A chat, please do so we have an opportunity to answer your questions before we have to wrap things up. If you do have other questions after the session, feel free to hit us up on Twitter or get a hold of your favorite VMC specialist and they can track us down. Any other last tidbits you wanted to show, Mandy, before we wrap things up? Or actually, you know what, let's jump back to the slides maybe and show the documentation.
Oh, absolutely. So let me go ahead and we will flip back and do our wrap-up slides. All right, so we're no longer demoing and we have sadly moved on from that. Here we go. I guess I'll talk to this one, right?
Sorry.
Unless Kim, unless you want to, it's up to you.
So
Don't mind.
again, just a recap of the benefits of these SaaS services. So again, the ability to accelerate your service and code delivery through a common platform and enhance the collaboration by being able to, build and share these blueprints as YAML. It gives you, again, the freedom of choice to be able to build agnostic blueprints and deploy to any cloud through through tagging and various options that you can declare at request time, but also gives you that ability to build out those really deep blueprints with cloud specific objects, and we saw all those in those options in the blueprint designer. So it really gives you the flexibility that you need to deploy into any type of cloud. And again, you've got that control and that consistency, so you can decide who can deploy where. We have things that we can apply from a policy perspective in terms of leases and whatnot. And again, deploying the same application the same way every time instead of from being deploying things manually and having things potentially change with human error. And also increasing that visibility from an IT perspective, being able to see which lines of business have how much, how many resources in all of your various clouds is really, really beneficial. Go ahead, Mandy. All right, and then these, when it comes to VMC, there are some tricks to the trade. So we want to make sure that we call out for you a couple of options and things that we leveraged when we were getting the VMC endpoint and cloud zone set up here. The first one is the actual product documentation, which is actually pretty helpful. And then the next one was a blog post that was written by one of our engineers that actually takes you through with screen steps, kind of the whole step-by-step process for getting the VMC endpoint set up. So definitely make note of those. Those are really beneficial. And a few more options as well. Of course, Cody DeArkland posts a ton of blogs about on the management website, the VMware management blog site. We have a hands-on labs that you can go ahead and try out, and you can get some hands-on time with cloud automation services. We also offer a free 30-day trial. If you're interested in trying these 3 services, you can visit our website and get more information about how you can sign up for those. All right, well, thank you very much.
Thank you all. We appreciate your time and passion in learning more about using cloud automation services with VMware Cloud and AWS.
Thanks, everyone. Please, if you can, take a quick minute to answer 3 easy questions around the satisfaction with this webinar. And thank you so much for attending. We will be sending out the recording and slides very shortly. Thanks, everyone. Thank you, everyone, for joining. Have a great rest of your day.